All right, so now we're going to look at multiplying rational expressions. So to multiply rational expressions, you factor each expression, and then you can multiply and then simplify. So if I look at the numerator of the first expression, 2x squared plus 4x, I can take a 2 out of the numbers, and then for the variables, I can take x out of x squared and x. So in factoring 2x out of the first expression, I would have x left and then plus 2. And then in the denominator, I have to factor x squared minus 4x minus 12. So I'm looking for factors of negative 12 that add together to be negative 4. So if I'm thinking about that, all right, 1 and 12 aren't going to work. 2 and 6, well, the 6 would have to be negative to make it the bigger number here. So negative 6 plus 2 is negative 4. So in the denominator, we would have x minus 6 and then times x plus 2. And then I'm going to simplify over here. X squared minus 9x plus 18. So I'm noticing I need factors of positive 18 that add together to be negative 9. And that tells me both of them are going to have to be negative. So if I did negative 1 and negative 18, that's not going to work. Negative 2 and negative 9 is negative 11. So I could do negative 6 and negative 3. So we have here x minus 6 and then times x minus 3 and then over 2x. And now what I need to do is simplify. So we can think of this as one big numerator, one big denominator. So I notice here I have an x minus 6 and an x minus 6. So I can cross those out. Also, I'm going to note if I cross one out of the numerator and the denominator, that would tell me there is a hole when x minus 6 is 0, and there's a hole at x equals 6. Then the same thing here, I can cross out 2x and 2x. Well, to make 2x 0, you would have to have x equals 0. So we cross out of the numerator and the denominator, so that makes another hole at x equals 0. And then similarly, again, we can cross out the x plus 2 and the x plus 2. And this hole here would be at x equals negative 2. And then if I look at this expression, it's x minus 3 in the numerator over 1. And I can get rid of that and just write this whole expression simplified to x minus 3. So we're going to look at another example and do the same process of looking at the expression, factoring, and then simplifying. So in the numerator here, we have x squared minus 10x minus 11. And then in the denominator, x squared minus 9. And then in the numerator, x minus 3. And then x minus 11. So I notice that this second expression, I'm going to put parentheses around them, but this is all set. So I just need to factor the numerator and the denominator of the first expression. So I'm looking at the first expression. We have x squared minus 10x minus 11. So I need factors of negative 11 that sum to negative 10. So I think right off my head, negative 11 and 1. So the numerator is just x minus 11 and then times x plus 1. Now to factor x squared plus 9, there's no x term, but 9 is a perfect square. And I remember that x squared minus 9 factors into x plus 3 times x minus 3. Some of you may need to write out a rectangle diagram to do that. I don't. And then here, it's x minus 3 in the numerator and then x minus 11. And then you just cross out what can be crossed out. So x minus 11 crosses out. And if you cross one out of the numerator and the denominator, that creates a hole on the graph. So I'm just going to write that down. This is a hole. And we have a hole at x is equal to 11. Because the denominator can't be 0. And if I plug in 11 for x, 11 minus 11 is 0. Same thing here. We have x minus 3 that would cancel out. And the expression x minus 3 is 0 if x is equal to 3, because 3 minus 3 is 0. And you can't have the denominator have a part that's 0. So as I look at the rest of my expression, we have x plus 1 divided by x plus 3.